Okay. All right. Hello, everybody. Welcome to the next in our series of seminars from scientists who have been working in kelp forests in the Northwest Atlantic. Today, we are privileged to have Dr. Larry Harris from UNH, who will be talking to us about his experiences and perspectives on kelp forests throughout, well, in the Gulf of Maine, as well as potentially in other regions as well. I'm really excited to have you today, Larry. And just before we start, do we have your permission to record this seminar and Q&A session?
Yes.
Awesome. Thank you. Thank you. Yeah, so I will turn it over to you if you'd like to share your screen or kick it off however you will.
Okay.
Share button. Yep. And you're going to select that screen. And now share. And now expand your PowerPoint.
Okay.
They're seeing everything.
Give me a second.
No worries. Yeah, you can just go into the slideshow if you want.
You can go right there. Click that button right there. That starts from the beginning. It'll fill up your screen. There you go.
Okay.
Awesome.
And then now you can just arrow.
Okay. Hi, I'm a few years retired, so there's obviously some updating will go on. And Jen Dykstra already mentioned last time that they're seeing cod, which is something I hadn't seen since the 70s. I came to UNH as an invertebrate zoologist and interested particularly in nudibranchs and predator prey in 1969 and retired in 2020. And last dive in the Gulf of Maine was in November 2019. That was COVID, just before COVID. So anyway, obviously sliding baselines is the focus. So I'm going to be talking mostly about changes in the benthic community that I've been observing. I like hard substrates, and because everything's right there in focus. And few thoughts on the problems of studying something that's always changing, and speculation a bit about future communities. Change has been the constant. Just when you think you've got things figured out, Mother Nature throws in a few changes and you have to go back to kindergarten and start over. Each new student, and I've had a lot of them, including John and Jen Dykstra, arrives for what is the normal ecological state, but that changes over time, and so and it keeps changing. But we're going to primarily focus on what I've experienced. Whoops. So main study sites, Cape Nettic and Star Island and White Island at the Isles of Shoals. We had a pretty long-term study site at Winter Harbor on the at the base of the Scudic Peninsula and Eastport. First time I dove in Eastport was in 1971, and it was already an urchin barrens. And until very recently, it remained that way. I grew up on the West Coast and learned to dive in Monterey Bay. And so my concept of a kelp bed was a macrocystis forest with an understory of kelps, or a subcanopy of the kind of kelps you're looking at in the picture. And then, of course, I come on, a turf and crusts. And so when I got to the Gulf of Maine and saw what are the kelp beds, it was quite a shock. Also, and this is a picture from a very long time ago, the understory was dominated by Chondrus crispus and Corallina officinalis, both perennials, and then of course the coralline crusts. There were lots of other algae, but those were the two dominant understory species. About 1980, we discovered an urchin front that was all along the south side of Star Island, which is including our research site, and was pretty mind-boggling. There had been a buildup of urchins below the thermocline at about 10 meters or so. And we actually, for a couple of years, would actually see small influxes of urchins above the thermocline, but that would attract wolf eels, ocean pout, and crabs, and they would be wiped out down back below the thermocline. But in 1980, it was just a massive front of urchins moving up. And from about 1980 to 1995, the Star Island site was an urchin barrens with even the coralline algae was grazed down. As you can see, there's a lot of granite showing through, but you can see all stages of the life cycle, juveniles as well with shell hash on them and larger. And in Eastport from 1971 to 2019, when we made our last urchin recruitment sampling in Eastport, this is pretty much what it looked like. We'll talk a little bit more about that later. And of course, with all the urchins, the lobstermen were very unhappy and wanted to get rid of them, of course. And the Japanese said, we have a market for those urchins. You just send them to us and we'll turn them into sushi. And I had been on sabbatical in 23 or 83, 84. And when I came back, a group of students got together and we did a feasibility study with the idea that there would be a seasonal fishery of urchins that would work with lobstermen that weren't fishing in the winter, and of course it didn't work out that way. It turned into tragedy of the commons, but the person doing what you shouldn't be doing for urchin harvesting if you want a sustainable fishery is Barb Childs, who Bob may actually have met her. She ran Pemaquid oysters in the Damariscotta for a number of years. But that's her as an undergraduate. Harvesting was taking place and such, and in the early 90s, we were beginning to see little patches of algae and and mussels, and even a few saccharina at the Star Island site, but they would then be wiped out by the urchins. But in 1995, all of a sudden, there was this massive bloom of Neosiphonia harveyi that just overwhelmed the system. And I know it was Neosiphonia because I took samples to Art Matheson, and he did the ID on it. And shortly thereafter, that algae attracted a massive set of middleless settlement. Everything you see on the wall here is covered with mussel spat. The big seaweed is a Desmorestia, and there's a codium in there, but you can't see them because they're nothing but mussels to observe. And in the spring of '96, the mussels had become this massive mussel bed that, as far as you could swim, it was nothing but mussel bed with very small, less than an inch, or about centimeter or so, middleless, with some hyatella stuck in. And then, out of nowhere, more sea stars than I have ever seen. It was just like the Milky Way. Both Asterias rubens and Forbesi were there, and they basically wiped out uh, the mussel beds, uh, and then, of course, when there was nothing else to eat, they started eating each other and dispersed. And then that fall, back came the Neosiphonia and the mussels and such. And this pattern happened for a couple of years until other species became more prevalent, and it became much more patchy and not as predictable. One of the predators that really benefited from this was Cancer borealis. And in 1998, there was a very large settlement of Cancer borealis juveniles. The bottom was just sort of crawling in some places with little cancer crabs, little Jonah crabs. And a couple of years later, by about 2000, there was about one adult Cancer borealis per meter square, and at least at Star and White Islands at the Hausa Shoals. This lasted for several years, and there were basically no urchins to be found during that period. The Jonah crabs have declined, but they've expanded their range. In 2011, we found them at Winter Harbor site, and in 2013, they were in Eastport. And they've certainly had an impact on the urchin populations in Eastport. But the removal of urchins led to a whole series of introduced species becoming more common. One of them was, of course, codium. It showed up in Booth Bay Harbor, and as a small patch, probably brought by oysters imported from Long Island Sound, where it was already present. And of course, instead of removing the codium, it was studied by several different researchers. Jim Carlton had a paper about it, and Art Matheson, and also, and such. And it adapted to the temperatures and then started showing up at the Isles of Shoals in the 90s and became prevalent after 95. Bonomosonia from Asia was very present. It became really common. This is the Traliella phase that occurs in the summer. In the winter, it's an arborescent epiphytic form with hooks to hold on to other algae. And as things went on, we used to see more and more of this Traliella form even through the winter. And membranipara showed up, and we first saw it in 1987 and up at the Isles of Shoals, and it just exploded. This is obviously on Agarum to show just how much it had exploded. But some of the observations over a period of time relating to membranipara, Agarum seems to be far more tolerant of overgrowth than Saccharina. Originally, membranipara colonized all of the kelp, and Val would certainly talk about that, but when it overgrew the growth zone at the base of the blade, it seemed to have a negative impact on growth. But one of the things that I observed, though didn't really study because I was too distracted with other things, that the Saccharina seemed to be initiating and maintaining some growth through the recruitment period of membranipara, and the colonies would be moved along the blades like a conveyor belt. And then when in the winter, the colonies would be actually lost off the ends of the blade. And so in the spring, you'd find clean kelp blades, which was kind of interesting. The abundance of membranipara and a bryozoan that wasn't, bryozoans were mostly a winter phenomenon in the Gulf of Maine, at least where we were working. And there was sort of an annual cycle of nudibranchs, particularly Onchodoros, that fed on electropylosa and stuff. Took a couple of years before we started seeing juveniles recruiting to membranipara, but then it wasn't too long after that that we started seeing more than one generation of membranipara. So you have adults and juveniles and egg masses on membranipara colonies in the summer, which was totally unique from what the original population cycle was like. And Mitrella went from being rare to common because they do feed on membranipara. And when membranipara first arrived, it was mostly on flat-bladed kelps and other such algae like somewhat on fucus, but then it adapted to virtually all algal morphologies. So you would find it on Desmorestia and Chondrus and all manner. What was interesting, I think, is that because the kelps were growing the membranipara off the ends over the winter, these other algae were actually providing them a better refuge for the bryozoan to survive the winter and reproduce the following spring. And of course, there was Botuloides, that violaceus that showed up. We started seeing that about 1980, and it became really common in the intertidal and subtidal for a number of years, and is still present. And then in 93, we found Diplosoma out at the Isles of Shoals. We had a tentative ID, and I called Jim Carlton, and he said, "Oh yeah, we've been waiting for it to show up there. It's been in Long Island Sound and such for quite a while." And then in 2000, there was the first rapid assessment, and down around Cape Cod, we ran into this creature, Didymnum, and found it first on the floats at the Coast Guard station at Woods Hole, and then also at some marinas. Just, it's an amazing animal, obviously. And my reference for it is tunicate from hell. Others call it pancake batter, and what have you. It actually showed up in Portsmouth Harbor at the Coast Guard station, and that coming winter. And there was a lot of interest because it was already in New Zealand and such. But I gave a presentation on community change and such to a dive club down by Framingham the following winter. And as I was getting to the end, I brought up, of course, the new tunicate that we had just discovered and such. And all these hands went up and said, "Oh no, that's been common on the ledges out in Mass Bay for years. And we've had taken lots of pictures and such." And then looking further, it turns out it was a major pest for oyster farmers in the Damariscotta much earlier, and probably came in on Japanese oysters in the 50s when they were being introduced. And this is a picture from Richard Klein, who was he shared these several images with me of his oyster farm in 1982. And you can see both Botuloides and Didymnum on there. And he said that it got so bad that they actually had to go to bottom culture because the Didymnum was just smothering the lantern nets. And of course, the codium was around for several years, and it began to accumulate growths. Mussels were settling on it, Neosiphonia, membranipara, etc. And so 2003 and 4, I had gotten to the point where I was thinking that, okay, we have a new canopy species in the Gulf of Maine, and have published on that. But I had a gap from 2004 to and 2005, getting hip replacements, and when I got back in the water in 2006 and jumped in the water, and there was a massive kelp bed, and instead of a codium bed, and there were certainly some codium in amongst the adult kelps, but it was a total shock. But I also knew what was going to be happening. So in 2007, returned, and sure enough, most of the kelp bed had been decimated because the kelps senesce after they go through sporulation. And so this was 2007 at the White Island site where it was a total kelp bed. There are certainly some kelps, but that shows you what resulted. And Art Matheson and a couple of graduate students had published a paper in '74 or so, talking about how Lacuna vincta was destroying kelp populations at Nubble Light, and obviously they were feeding on senescing kelps, and they weren't the reason that they were senescing. And I think Val Gerard has also published on membranipara being the cause of it. And at the same time, water temperatures are rising, and they aren't declining as much in the winter. And this favors introduced species over native species, favors southern species moving north. What you've got is temperature, habitat alteration, overfishing, introductions, and southern expansion, a perfect storm for increasing changes in benthic communities. There are now blue crabs, not only in Great Bay, but all the way up to at least the northern end of Casco Bay, black sea bass, tautog, all these southern species. It's interesting that Ojeda and Dearborn in '89 reported black sea bass and tautog at Pemaquid Point when with some of their gill netting. So they were appearing from time to time, but they weren't really established. And temperatures have been changing. And the blue line at the bottom is when I was doing a panel study at the Coast Guard station and at the mouth of Portsmouth Harbor in Newcastle. And then the second line, 96 to 2005, is when Jen Dykstra repeated that panel study. And then the red 2015 to 2021 was when we added that line for the benthic, the 50th anniversary of the benthic meetings, which started in Spalding Hall with a few people back a long time ago. Anyway, and also 2021 was the warmest year on record for the Gulf of Maine, and though that may change this year, we'll see. But what's really important to me is that what was happening in February and January. Because one of the things that we noticed from diving through the winter is that 4 degrees seemed to be a break point where above 4 degrees you'd find crabs and such out active and foraging and that and then below 4 degrees they'd all be gone and hunkered down. Though I have a vivid memory of diving with one of my former students in Gosport Harbor in February because he needed to sample apperhace, a little winter active snail that occurs in Gosport Harbor, and it was February at night, and there were Cancer aeratus up and around, walking around and such. So what we saw didn't necessarily mean that they were always inactive in the winter, even at colder temperatures. Also, there's been significant changes in the understory composition, and until 1980, when the urchins took over, it was basically a shag rug of Chondrus crispus and corallina, with, of course, other species mixed in. From 80 to 95, urchins and crustose corallines dominated. And then after 95, it transitioned to introduce red algae, colonial tunicates, and such. And so this was at Star Island in 2012. 6 of the dominant species in that benthic community were introduced. And this just shows percent cover breakdown. And on the left, you're talking about tunicates. There's filamentous reds, but it was Bonomosonia in the summer that was really dominating a lot of the space. And when you're talking about a benthic community that looks like this, all you can think is, how about ecosystem services, and how does this system function, and what is happening to the community. But then we came back the following year, and total coverage by Dasyphonia, which had been down in Massachusetts Bay for some period of time before that, but it was just 100% cover on the surface. And there were certainly other species down below, but it was just kind of a mind-boggling explosion. And that's a couple of years later. Dasyphonia was obviously the dominant. There is Chondrus and corallina, and even some Saccharina here and there, but mostly it was Dasyphonia in terms of stuff. So Dasyphonia obviously is now a significant component. It's even out on Cassius Ledge, as pictures from John and Liz demonstrated. And I don't know how far up it's gone, but it's certainly spread. There are certainly native perennials like Chondrus and corallina to add to the complexity. but the associated fauna is changing also with new additions, food sources, and structural complexity. And probably really interesting is the fact that Farrell et al. In 25 in Science introduced evidence that some of the understory algae, probably mostly the introduced ones, more so like Dasyphonia, are releasing chemicals that suppress reproduction in the gametophyte stage of kelps, which may be one of the factors with the decline that's occurring. So actually adding in the component of chemical warfare is something that really hadn't been on the radar much, and so this is a really significant addition to how we look at what's going on. And so that again is the complex community that's was occurring, and the little white dots are what I wanted to point out. They're actually Matrella. So back in '83, I had gone and sampled a whole bunch of algae, particularly chondrus and some of the filamentous reds, and looked at the associated fauna, and then we did the same thing in 2015. This was at Cape Nettic, but we did chondrus and Dasyphonia, and this is how that happened. So lacuna is on both types of algae, even seems to get along fine on Dasyphonia. Middleus edulis used to be really dominant, and now it's not nearly as common. Amphipods are more common on the algae now than they were, and we have two additions that weren't there in '83. Convoluta, the little acial flatworm that is predatory on plankton and on copepods, and particularly settling mussels, and also Mitrella, which we knew about from Bob Whitlatch's and Rick Osmond's studies south of the Cape, but now it's a prevalent member of the community, and particularly on Dasyphonia. And this is sort of what we were dealing with. So you've got Mitrella down here, and these convoluta were just amazing in the earlier stages. They're not as common now as they were then, but it was pretty amazing. So the understory is now basically dominated by ephemeral species, Dasyphonia, Bonamasonia, etc. And there are now mesopredators that did not occur in the historical community. These predators act as larval filters and prey on juveniles and colonial filter feeders like membranebra. As the kelp canopy declines and the understory is changing, composition and supporting an altered associated fauna impacts on higher trophic levels are obviously in transition too. So all at the same time as all this other stuff is going on, both sea urchins and sea stars have had periodic die-offs in the Gulf of Maine. Urchin die-offs have not been on the scale of those in Nova Scotia, which of course were almost total in shallower waters. And actually, I was going back through my dive logs, and I first observed sick urchins off of Babb's Cove in 1980 before I discovered the urchin front on the southern side of Star Island. There were just little urchins that were sitting on the kelps and stuff, but not attached, and obviously the beginnings of the die-off. Sea star die-offs actually happened in the 2000s. There were some ups and downs in recruitment back in the 80s, and that was due to a ciliate that was causing parasitic castration of the male Asterias. But that wasn't we weren't monitoring it in recent years, so I'm not sure if it's still happening that way. And of course, as the Gulf of Maine gets warmer, the die-offs could be more devastating. Urchin die-offs lead to regrowth of benthic communities, algal dominated, but sea star declines seem to benefit bivalves, and particularly Cropidula, which is now much more common than it ever was. And there's a paper that's in press now that by Caitlin Van Volcom that and et al. That documents that change. And since I'm really interested in nudibranchs and have been for a long time, I was referred to an underwater photographer, Alex Schur, who was diving off of Cape Ann and ran into a very large breeding population of the European Dorid nudibranch, Doris pseudoargus. This is a big nudibranch, very similar to a lot of the big Dorids on the West Coast, but something that did not occur in the Gulf of Maine. And it's now found from Nova Scotia to Long Island Sound. It's the first generalist sponge predator in the Gulf of Maine in shallow waters. Certainly Henricia is there as the sea star, but it's not significant as a controller of sponge populations. And sponge populations are also dealing with introduced colonial ascidians. So it'll be interesting to see how this new sponge predator has, what effects it has over the long term. And this is in shallow water feeding on Alachondria panacea. And in deeper water, this is actually from some of the first populations on feeding on Isodictia, which now is very rare at this particular these rock pinnacles where they were first found. So we've actually got a low diversity system dominated mostly by generalists with wide tolerances for abiotic and biotic stressors. Unlike the West Coast and Europe, the water temperatures fluctuate tremendously and such. So if you're in shallow water in this part of the world, you need to be very adaptable physiologically. Evolution is taking place. See changes that are obviously based on adaptations, differential survival is the way I would look at it over time. And uh, and it's obvious that one has to be aware of what the system was and how the system is changing and has been changing over time. And and ecosystem services. This was one of the things that I keep bringing up. I was at a meeting at UNH a number of years ago with some funding agencies, and there were two groups. There were people who were from the University of Maine who were studying river herring runs and life cycles and fisheries and such. And then there were people that were interested in introduced species and such. And it was interesting because when the whole idea was suggesting areas of study, talking to the presentation on invasive species, you could have heard a pin drop. They just really weren't interested. And when you talk about, oh, we need to do more on the fisheries, and boy, they were really interested in wanting to fund as much as possible. As I left there sort of spitting nails and saying, you don't know what you're talking about. And of course, this is when John Whitman took this picture back in the 70s. And we used to see cod at the Asa Shoals and such. And then we didn't see them anymore. And of course, Jen said that recently she's been seeing some young ones and they're diving. So maybe after many years, they're slowly beginning to make a bit of a comeback. Same thing happens off of Nova Scotia or Newfoundland, where they had to close the fishery because it was in bad shape. And after 30 years, it's barely beginning to show up again. And could all those changes in the benthic communities be inhibiting the recovery? And also the trawling that just clear cuts the bottom of in deeper water that's would remove the habitat and a lot of the food for the juveniles of cod could be could be part of the problem. So kelps are declining, and it's possible they may disappear in the southern Gulf of Maine. Who's going to fill that canopy niche? Guadalupe or sargassum species? That's a question. I haven't got a clue. But there are also other kelps that are out there possibly waiting to be introduced. And are chondrus and corallinus still going to be dominant, or are there going to be other perennials that come in? Because most of the turf algae is ephemeral. So the understory community is unstable and likely to continue to change. Lots to study in the future. And that's it.
That's great. Thank you so much. That was really awesome. Thank you. We are now we've got a couple of common questions that we ask people. Folk who are part of the group have the list, so it won't just be me asking, but also if people have other questions, feel free to virtually raise your hand and I can call on you just to run a little interference. Um,
I can go back to in person rather than.
yeah, that's great. That's great. Have a conversation. I just wanted to kick it off with we kind of have two big questions, or we have a couple of big questions that we want to ask everybody, given that this working group is focused around thinking about the entirety of the Northwest Atlantic. Um, and so the sort of first question is, how does the Gulf of Maine or your work in the Gulf of Maine, how does this inform us about sort of the larger ecology or history of the Northwest Atlantic? So not just what's happening here, but we have researchers as part of this group that are going all the way from working in Long Island all the way up through Newfoundland and even into the Arctic. So what do you think the Gulf of Maine has to tell us about sort of the larger ecology of the Northwest Atlantic?
Well, I think the climate change and introduced species uh, are certainly something that are pretty much universal, and that overfishing has been also a universal issue. Lobsters are pretty much gone from Long Island Sound now from shell disease and such. And I've been in communication with a lobsterman who works out off the Isles of Shoals and stuff, and they're seeing the shell disease in increasing amounts, and so temperature is obviously uh, facilitating that, and then the disease and such. And one of the things with all the introduced species and such, the fact that there's this allochemical war going on potentially amongst some of these species, and particularly new species that haven't been uh, part of the system that allowed for long-term adaptations uh, are certainly something that needs to be added to our trying to understand what's going on. And
That's great.
oh,
Yeah, any follow-ups on that from other folk?
yeah,
Bob?
Hi. Hi, Larry. I have a question. It seems to me that we were seeing a transition in the 1990s to more recently from Cancer aeratus to Cancer borealis. Did you see any increase in borealis relative to aeratus in your neck of the woods?
uh, yeah. Well, Borealis exploded, and of course, uh, you were doing a transplant study in Casco Bay that just happened to happen when Borealis was in extreme population density and such. Aeratus is still around, but Borealis became really common, and I'm not really sure how common Aeratus is now. We haven't been I haven't been in the water since 2019, so I have to. And Jen is not here. So,
Yeah, I stopped diving in 2021, but I do keep track of the carapaces I see along the coast. And on the outer coast, it's almost exclusively borealis. It seems like as you move up towards the Darling Center, you do get more Iridotis. But I think back when Alvaro Palma and Carl Wilson were working, I think Iridotis was most common in our area.
Hmm.
okay, well, one of the things that uh, I noticed a number of years ago is Borealis is totally uh, defenseless against seagulls.
Yeah, it's true.
So, because they adapt to, they're adapted to avoid lobsters. So they do this rather than this.
Right.
And so I've actually watched at one point a gull trying to attack a good size Iridotis in the estuary in the intertidal. And it actually fended off the gull and got to escape down into the algae. Whereas, and years ago, I was teaching a course for uh, a 1 week course for at the Shoals for school teachers, Introduction to Marine Science, with blanking. Anyway, and we did a tour all the way around Appledore and picked up every crab carapace we could find along the intertidal or the just above the intertidal line and with the where the gulls were nesting, and it was almost exclusively borealis.
Mhm.
And with some green crabs, some carcinus in there. John, is you had
Oh, John,
your
you're muted.
Um, we followed the massive medalist recruitment event that Larry talked about all the way up to Portland. And we saw a massive increase in Borealis with, subsequently, and sea stars as well. So we think a bottom-up effect had a positive, effect on Borealis populations. But Larry, I have a question. I have a lot of questions, but thank you for an incredibly valuable presentation. I mean, no one else has your perspective, and it's super valued. A specific question. In 2006, you said there was a big increase in kelp, and went back to kelp, I guess at Star Island. Uh, that's really interesting because we're interested in the resilience of the Cassius Ledge kelp forest. And do you think it was a cold? Yeah. Why did the kelp come back? I mean, obviously a huge recruitment event, but was it particularly cold that year and, favored greater survival, or do you have any ideas?
Jen and I are going to be looking at water temperature on that. But one of the things, and I suspect because the codium was becoming more and more overgrown with all manner of epiphytes and epibionts, and I think of some winter storms uh, did a number on the population. I mean, you could actually see age classes of the codium. So there was this size, and so the 3-year-old plants were substantial in height, and I think they don't have the holdfast that a kelp does, and so I think they were just stripped out.
Yeah.
And Bob's presentation 2 weeks ago gave me some perspectives that I really didn't have before, and that is that the gametophytes are perennial, not annual. And so there undoubtedly were still gametophytes out there in the system, and they were beneficiaries of a massive removal of the codium. That's the speculation, but the abiotic factor that led to that stripping out of the codium, not all of them were gone, but there were the ones that were left were just straggly remnants of what would have been a healthy big codium plant and such. And so the kelp, it was really striking, and because I wasn't in the water for 2000, part of 2004 and to 2006, I can't say exactly what it was, but I need to go back and look at storms and water temperature, because that could really be an effect.
Okay, thanks.
And now I'm scrolling through and trying to see what 2006 looked like on some of these. Oh, that's not sea surface.
Well, I would look for 2005 winter into 2006.
Yeah, because I know this
Those
year,
kelps were really
yeah, this year we've been seeing quite it's been quite cold, and the kelp has been quite large and abundant. It was even
Good year for kelp.
yeah, even diving in Salem last week, it was 10C at
wow.
yeah, I've never seen it like that down, particularly in July. It was crazy. My team was unhappy because we were not quite prepared for that.
Yeah.
So another question we'd like to ask is, do you look at the Northwest Atlantic as one sort of large contiguous system, or many separate systems, each with their own kind of unique systems or unique stories? Sorry.
I'm more unique because we have a study site in Eastport and also in Haddon near Bar Harbor and on the Scudic Peninsula at the base of it and such, and and then you've got the outer coast of Nova Scotia that is warm, more like the coast south of Cape Cod in terms of temperature and such. I can remember, I haven't done much diving up there, but I went with Terry Gosliner. John would know him. He's a nudibranch person, but we went up to Prince Edward Island in late summer many years ago and made a dive off of Prince Edward Island, and it was warm. And then when we got up to Cape Breton, we actually contracted with a lobsterman to take us out so that we could go down below the thermocline or at least I thought we were going to go below the thermocline. And we got out to, he didn't have any instrumentation uh, on his boat. So we said we wanted to go to about 120 feet. Uh, and and so he threw a cod jig over the side and and measured it. And yeah, and sure enough, we were at 120 feet, and there were cunner swimming around, and there were the water was warm. There was no thermocline. We were in, it was very clear. There was some algae growing,
Wow.
probably Tylota and such, but you know, total education that it varies tremendously depending on where you are. And so I would assume that, in places like Prince Edward Island in the winter are, frozen over basically. And yet in the summer, it's like Cape Cod. Uh, and and the outer coast of Nova Scotia is, gets definitely warmer, whereas the Bay of Fundy and the Passamaquoddy and Cobscook bays are definitely colder than that because of all of the heavy mixing.
That's a great point.
Sorry, guys, I have to go, but wonderful. Thank you.
Great to see you, John.
I
Yeah.
have to go too. Take care, folks.
See you,
Yeah,
Bob.
looking forward to your time.
I'd follow up, Jarrett. I don't know on that.
Yeah, yeah.
Larry, if there are, so it's not geographical regions that are maybe, or it's not one whole story, it's not, but are there how many oceanographic condition stories? Who says, oh, Prince Edward Island is warm, but it looks like somewhere else. We could put together various pieces of a jigsaw and say these regions have one story, whereas these places that are cold and mixed have a different story. Or I don't know, does that kind of make sense as a question? It's maybe not, lines latitudinally that we could divide, but are there still grouped areas? How many different stories?
There are also differences close in. And a good example is around the Isles of Shoals. We had years ago, we had stations at 100 feet, 60 feet, and about 25 feet or so. And there were two thermoclines, one at 10 meters and one at about 25 meters or so. And below that, it was 4 degrees centigrade through most of the summer and such. So it would get warm above, but at Cape Nettic, and this is going to relate to what Jared just said, at Cape Nettic, when the wind is blowing substantially offshore from the west, it pushes the warm water out and you get upwelling. My daughter went to the beach just a week or so ago. Actually, last weekend, we had been at another beach a couple of weeks before, and people were swimming and having a great time. And she went to a beach near Nubble and had her mask and headed into the water to snorkel, and as she had done before, and turned right around after she got to knee deep and walked right back out because the temperature was like Jarrett just said. And you can see it on satellite imagery. It can be orange at the shoals and blue at right along the coast. And I've argued with oceanographers that say, oh no, that isn't possible, but it is, and it happens on a regular basis. You know, diving one day at Nubble, the water's nice and warm, and you're just really enjoying yourself. And the next time you go in, it's teeth chattering sort of thing, and it's just about what happens with the winds and such. So you get these localized upwelling events near shore, and but it doesn't seem to happen so much out 10 kilometers offshore at the Isles of Shoals. Water moves back and forth, but doesn't necessarily. I've never experienced it out at the Isles of Shoals and at our study sites.
That's wild and really makes me think. I mean, I guess one thing we share in our past is our time at the Bodega Marine Lab. Um, and it really makes me think so much about how when I was on the West Coast, so much of kelp forest ecology and just understanding that system in general is all about understanding upwelling dynamics. And it's just not, I mean, there's sort of internal waves and the things that John has brought to the fore, but we don't really think about it in nearly the same way, particularly in terms of this idea of creating, Katie, I really like your idea of creating these sort of like oceanographic condition story or these, yeah, the sort of jigsaw idea.
I've been thinking a lot, and I agree, Larry. I think the whole near shore, all of the models we have, all of the large scale products, everything, it never touches the shore. And there's so much that happens in that is like really small scale, either temporally or spatially. It's like there's upwelling here. One day, I had our sites here, it's the same. I was diving kind of a long-term project at a single site, and we were there every month for 3 years for 2 weeks, or for 1 or 2 weeks. So we saw varying conditions, but it changes drastically from now to 6 hours later. It's like the first dive of the day and the last dive of the day are not the same thing. You can have an entirely different water mass come in and it doesn't feel the same.
Yeah.
No.
Yeah,
Yeah.
go ahead, Jared.
No, I'm just like pondering all of this. This is a really interesting idea.
Years ago, I was out visiting Paul Dayton at Scripps, and I went out with uh, Taya, or not, oh come on, Mia Tegner, sorry, and actually an undergraduate who had worked in my lab uh, previously, but it was during the period when there was a strong El Nino and a major storm, and Queen Elizabeth couldn't go to Ronald Reagan's ranch and such. And so it was major El Nino temperatures. So he went out to their kelp bed study site, and there were 2 or 3 little sickly looking stipes of kelp macrocystis to the surface. And, it was just crazy. The temperature change. And of course, there were also urchin harvesters around in their natural, their study site, which, that's one of those things you can't deal with necessarily. But recently, Ed Parnell and Paul and some others published a paper on the kelp bed declines in Southern California. I reviewed that paper a couple of times, and Ed sent me some video of one of their study sites, and it's so depressing. I could hardly believe it. There was absolutely no macrocystis. There were a few very uh, straggly subcanopy uh, kelps and such, and it was just a barren area, but there weren't I didn't see a single purpuratus. There were franciscanus, the big red one, uh, you know, scattered here and there, but it didn't look like there were enough of them to cause a barrens. And the video is just depressing in the extreme. Interesting, but depressing what's going on. And it hadn't gone that bad. Actually, Nubble, because of all the upwelling and such from, variation, it still has kelp, more so than probably around the Isles of Shoals.
Yeah, I'm curious. I haven't looked at the underwater research. I didn't teach underwater research this year, but they went out to the backside of Appledore, which we've been monitoring for years, and I'm really curious to hear what the kelp looked like this year. It even
Uh,
went into a barren for 2 years, a couple of years ago, and then now it seems like it's popped back, or it did last year anyway. It's back to being a very lush bed.
I Liz Kinsing just sent me some. She sent it to all of the divers at UNH, and some images that that included one of the images was from a kelp study group
Mhm.
that a training,
Oh, it's
and,
the class, yeah.
and they were just it was a lush kelp bed.
Hmm.
So it could very well be that
Yeah.
and the exposed sides of the Isles of Shoals probably does get some upwelling more so than on the other side. And of course, uh, Gosport Harbor gets warmer than out on the outer areas also. So
Yeah, I have some temperature loggers that I had out there for quite some time, and you can watch in the winter everything converges, but in the summer you can have a huge difference between the two sides of the island. It's really quite substantial. There's something very, I don't know if it's it's some form of upwelling or mixing that happens on the exposed side, and we find signals of it in the intertidal as well. Like it just keeps coming up again and again and again as a story. Um,
Hmm.
yeah, I think there really is something to this sort of, I don't want to
I
say micro scale, but this small scale variability.
I have a student right now who's trying to Greta. I'm not sure if you've met her,
Mm-hmm.
Jared. Yeah, but we did a bunch of dive surveys in the St. Lawrence looking at subtidal communities, and she's trying now to put together the environmental variables that she's going to use to kind of discuss and look at this. And she wants some sort of, I've been really pushing the upwelling idea. She's
Mm-hmm.
super interested in it. But what is available and how can she calculate something across a large number of sites that will give some comparable index that includes this idea, which sites get more, when, how do you extract that from satellite temperature data or something? How do you see these small scale
Yeah,
upwelling things and kind of calculate them for a bunch of different sites? And she's trying to pull
yeah.
something together. And I think it's super important in our system as well. And it's just really hard
well,
to
and it's so localized that for
yeah,
oceanographers, they are thinking on a different scale.
yeah,
Yeah.
Uh,
exactly.
Years
Exactly.
ago, I had an undergraduate working in the lab, and I had her looking at satellite imagery on a very regular basis, daily sort of over a summer, and you could see the variation along the Cape Nettic area where the upwelling was taking place because it would turn blue and then go back to orange and such. And then one of my former graduate students put hobo recorders at Nubble and at the Isles of Shoals at our study site. And Nubble was like this, and the Isles of Shoals was like that.
Mm.
So, and just to verify, I'll have to find that data
Mm.
somewhere in the piles behind me.
The turtle is holding on to it, I think. You should ask Aunt George for the
All of those folders on the side are slides.
Nice.
That go
Um,
back
I
seven.
have a question, Jared.
yeah, go for it.
I don't know, it seemed to me, and thank you, Larry, for the presentation. Everybody, I've been seeing things in the chat. It was really amazing to see the progression through and trying to draw out the stories. You did a really great job. One of the things that seems to me, it's like the constant change. But is there more change? So it's flipping more often, or we have more states, it's happening more quickly. If that's the case, is there a point at which it's too fast for any kind of system to do we get to a place where too many changes mean we, I don't know, lose any semblance of the resilience that we never get back to? Because it seems all of those changes, we go from one thing to another thing to another thing. Does that just mean we're on this path and we're going through different states and that's fine? We'll get somewhere and it's different and it will keep changing and it will be different, but it'll be, or at some point does that fall apart? Do we lose?
I I would guess that in the southern part of the Gulf of Maine, the changes are occurring faster. Back in the 70s, one assumed there was kelp beds, and there weren't a whole lot of big changes till the urchins came in. There were undoubtedly some introduced species and such, but we didn't see Botuloides until 80, even though it was already common in the Damariscata. And Didymnum was a pest, but nobody was studying invasive species out of the Darling lab. In fact, I couldn't find it, but I have this memory from a long time ago of one of their publications from the Darling Center that had a picture of what obviously was Didymnum, but I didn't know that because this was back in the 80s. And they labeled it a sponge. It was a big.
That's a big switch of identification, not.
Somebody had taken a picture and they just assumed it was a big whitish sponge covering this rock on the bottom. And I actually communicated with one of the secretaries or admins at the Darling Center to see if they had any recollection of which publication that was. I could have gone to their library and found it probably, but it's one of those. I'm very visual and I still can remember that picture because I was so taken by it. I'd never seen a sponge that big and one that looked like that. So
That makes me think of another, I don't know, Jared, with Fanny and Kira. I was talking about how much of our understanding of the systems is driven by who and when. And clearly, those studies were happening. So somebody who can't identify tunicates is going to have a very different impression of what's going on in a system than somebody who is a taxonomist, for example. So kind of the lab that dominates the story in a region, who the leader, who the head of that lab is, how much of an impact that has on our understanding of these different systems. Because each system kind of has a different person in charge of.
Yep.
John Himmelman in the St. Lawrence did not have the same perspective as Bob Stenick in the Gulf of Maine, right? They weren't looking at the system from the same background, really.
Yep. It's the old researcher degrees of freedom problem.
Yeah.
Yeah.
John and I had an argument one time because
Well, that would hard to do. He didn't have arguments with a lot of people, did he?
no, but I had not seen cannibalism in Strongylus symptrotus. And he said that it happened and they would see it. But we hadn't observed it. And that is until when Dasyphonia arrived at the Isles of Shoals and along the coast. I had some students, and we were going to do a feeding trial of several different algae, and we had one little bin that had only Dasyphonia in it, and we put in a bunch of small urchins, and I mean they eat Tylota when they're desperate. And agarum and whatever, even Desmorestia, they'll chew on it. They would not touch Dasyphonia. And we actually had cases of cannibalism where some were attacking other merchants. And that's the only time I have ever seen it, period. So I can believe what Doug Rasher's group said about allelochemical issues with Dasyphonia and such. It is really toxic compared to a lot of the others.
Which is funny because Arbacia loves it.
Wow.
Yeah. Yeah. So some stuff coming out of Colette Feehan's group. We're finding that it's sometimes even eaten over kelp. It's one of the things I dream about in the future. What happens if Arbacia really comes around the Cape? How does that change things?
It probably will.
Yeah.
Yeah. It wasn't that many years ago. I have to go back and look at my dive logs, and we started seeing black sea bass in Portsmouth Harbor.
Mhm.
And I'd not ever seen them before. I knew what they were, but and obviously in the summer, the Gulf Stream brings in larvae of
Mhm.
butterfly fish and puffers and all sorts of things, but they don't make it through the winter. And but the black sea bass were definitely there, and tautog are in Great Bay, and
Mhm.
one of my former students, Chris Wells, who's at Bowdoin,
Mhm.
they're trapping blue crabs
Mhm.
up around Bowdoin, up at the northern end of Casco Bay,
Yeah.
and such. So it's a totally different system.
Yeah.
But and Long Island Sound is probably a harbinger of what Mass Bay and our region up through Casco Bay and such. The currents down here are different than what the northern part
Yeah.
of the Gulf of Maine and such. Mostly, there's a current that comes down to Penobscot Bay, and then it goes out. There's another one that comes back in and down the coast. So there's still currents coming down, but Penobscot Bay is sort of that break point.
Yeah. Do you think change across, you have this tremendous story of change. Do you think change across the Gulf of Maine or the Northwest Atlantic in general has been predictable, or has it been fairly stochastic?
Uh, well, when each of these new species that show up mix the game. So I think there's some stochasticity to it. The weather isn't totally predictable from one year to the next, and so it's hard to say, but I would think that there's certainly some unpredictability in there that
Yeah. Do you think there's sort of particularly in, I guess, stepping back a minute and thinking about the Northwest Atlantic, like what's sort of like the biggest shared driver maybe that could help us understand change?
uh, well, of course, we haven't talked about acidification at all, and that's sort of there on the side, but
Hmm.
uh, I think climate change and
Hmm.
such, uh, and who knows what might happen if the Gulf Stream is disrupted in the downwelling uh, in the North Atlantic breaks down. But Europe's now going through heat waves that they've never had before, and uh,
Yeah. Yeah.
droughts and fires, and you know,
Yeah. It's wild.
Maybe
Um,
kind of related to that. I don't know, Jared. I mean, climate change, I agree that like, and that's huge. It can be many things. So it's complicated to, I'm not sure how good we are at understanding all of those, what will change. But looking back, because you talked a lot about invasive species as well, right? Which are linked to climate change, but not necessarily. I mean, would the impacts of invasive species have been as, are they, if we separate those out, what's the importance? Is the changing temperature and acidification kind of a more important thing going on, or the introduction of all of those turf species? Because that is then driving the new understory you're seeing. If we didn't have those, but we had the climate change, what would be the
well, also, you have to add in the fact that overfishing has just totally depressed the upper trophic levels and their role in all of this. And, there maybe never would have been if cod were still the dominant species in the Gulf of Maine. Would there have been an outbreak of urchins on the scale that led to this essentially elimination of kelp beds below several meters, and and then overfishing in a totally unsustainable way. Uh, you add that in, and the way the urchins were removed, just I can remember, when it first happened, and then there was all this interest in and how do we get rid of these things? And the Japanese said, well, just send them over here. And Maine Sea Grant hired Ben Baxter, and DMR had Bruce Chamberlain, and they were instrumental in promoting an urchin fishery and such. And then it really started in 87. And it was basically take everything to the processors and let them pick through and you and it was year round. There was no off season. It's just and I started getting calls from harvesters. Dave Quimby was one of them, and who's has a uh, uh, biological supply company, amongst other things, and uh, from up in Maine, and he was asking me, how fast do they come back? How fast do they grow? And 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 then well, we're not overfishing them or anything. Well, it turns out as the conversation went on, we're now harvesting at 60 feet rather than right on the kelp line at the near the surface and such and such. And it was harvesters and a couple of processors that actually forced the legislation through the Maine the legislature to require DMR to manage the urchin fishery because DMR didn't want to do anything. And so they started off by saying, well, we're going to close the fishery to new licenses, but we're going to leave it open for a little while. So it ended up with about 3,000 licenses. And then they closed it for 1 month. And all the harvesters came down to Massachusetts and New Hampshire. And when they found out that Maine wasn't going to allow anybody but Maine residents to have a license in Maine, uh, there were some really nasty encounters between the Maine fishermen and the Massachusetts and New Hampshire fishermen and such. Now, I actually got a call from the head of New Hampshire Fish and Game, who uh, I knew, uh, and he said, what do you think about this thing?" This was in 83 or 93. And I said, well, just copy their regulations. Let Maine set the regulations and you just copy them, which, of course, that meant that Maine people and Massachusetts people couldn't harvest in New Hampshire. But yeah, uh, but that was sort of the way it all started. And, I'm still on the Sea Urchin Zone Council. I was elected in 2000. And because I'm from out of state, I would never get any of the research funding. So I have credibility.
Nothing to gain.
Yeah. Well, Carl Wilson was a zoo major, and I was his advisor. Taught him invertebrates at UNH before he went to work with Bob.
Thank you so much for your time. One last question that we like to ask everyone is, do you have a favorite story from your research career?
Okay, I'll give you one. It isn't the Gulf of Maine.
Okay.
It's okay.
I had just done a sabbatical in the Marshall Islands in Majuro, which is an atoll. Overfished, you know, kind of crazy and such, but still pretty spectacular if you like coral reefs, and I do. And we had a chance to go to the Christensen Research Lab in Madang in Papua New Guinea. And we got there, got sort of checked out and such, and we went out to the edge of the barrier reef and of the lagoon that is the uh, off of Madang and such. And I went down to about, 50 or 60 feet. I don't remember the exact depth. And I just spent a year in the tropics on an atoll in the middle of the Pacific. And I'm sitting there, sort of sat down, and all I could think is, I'm in God's workshop for coral reef diversity. And, that part of the world is so mind-bogglingly diverse that it's just hard to comprehend. The, anyway, there are lots of, you know, I actually my favorite place to dive in the Gulf of Maine is in Eastport and up in that the Cobscook Passamaquoddy Bay area, because the diversity is so much higher. You don't have to go to 100 feet to get a lot of species that are in diving, you know, 10 meters at low tide, which of course is 25 feet down. and such. And it reminds me so much of diving at Friday Harbor and that system, because I took a summer course, a couple of summer courses at Friday Harbor. And it was kind of mind-boggling. Actually, Paul Dayton was in that course. He was just a brand new graduate student with Bob Payne. So it was really interesting. And we had in common that we'd both spent a year in the Antarctic. I did it when I was an undergraduate studying rotifers.
A full year throughout the winter and
Yes.
wow, it's quite the experience. Not a seasonal.
Well, it was supposed to be seasonal, but my mentor at that time, who was a comparative nutritionist, but working with nematodes and rotifers and stuff, came down and the research lab was going to have one graduate student and one technician for the winter, and it was really well stocked and stuff. And he said, well, you know, it's a shame that nobody's going to be here for all and make use of all of that. And I said, well, I'd be willing to stay on. That's how I ended up wintering over in Antarctica at McMurdo Station.
Wow.
Great.
But
Well, great. Well, thank you so much. We really appreciate your time and, the comments we've gotten as folk have had to trickle out. Yeah, really enjoyed it. I'll be putting this up on the playlist, and yeah, thank you so, so much. This was really wonderful.
my pleasure.
Excellent. Great to see you.
Yes. I'll tell you, I'll I'll now that this is over, you wanted to hear a little bit about Massachusetts Bay.
Oh yeah, I'd love to.
It was early on in the 70s, and it was an environmental impact study to evaluate sand and gravel mining to extend the uh, airport runways at
Hmm.
Hogan. Of course, the Department of Transportation, who was doing uh, the extension of the airport, hadn't been consulted. They weren't interested in that, so it was a bit of a boondoggle. And I was very early in my career and not all that experienced at Benthic Community Studies, and uh, so I have a second PhD from the College of Hard Knocks
I love it.
for that experience. Yeah.
Yeah, yeah, we definitely all go through that. Oof. Interesting. Yeah, it's really wild how that's kind of come back, I guess, in the end. With now we have an artificial reef that's been installed to handle some of the airport expansion and quite a bit more. Huh.
Yeah, well, and most of the diving was close to 100 feet. And it
Hmm.
was also a lot of grab sampling,
Hmm.
and then analysis of stuff. But it was, and you're doing quadrat studies at 100 feet on a sort of a cobbly bottom, and you're doing meter squares and such, and you look over a ways and there's a big species of sponge that you have never had in any of your quadrats. And there's some more over there, and there's it's so random and
Huh.
hard to. So yeah, anyway, it was an interesting thing. It was run by Department of Marine Minerals out of Tiburon, California, that just
Hmm.
came and said, we'd like to make this study into a national study, and
Mm.
we'll give you whatever you need in terms of funding and stuff. And too naive and too wet behind the ears to say, you have no business being in charge of this and doing this at this time in your career. But so, when you're a young assistant professor, the world is yours to conquer.
That's for sure. That's great. Well, thank you so much. And yeah, this is great. We'll be continuing these and can't wait to sort of put it all together. There's a lot to chew on
Looking
it.
forward to learning some
Yeah.
more.
Yeah, thank you. See y'all.
So
Thank you very much.